Hello, welcome to our Edge AI session. I am blessed to have Marco Carrer together with me. Eurotech has been implementing a lot of Edge AI implementation already, and so I'm pretty sure we're going to learn a lot about those implementation in the session that Marco is going to do now. Marco, the floor is yours.
Excellent. Thank you, Philippe. Thank you for the introduction. So let's get started over here. Excellent. So good afternoon, everyone. It's a pleasure to be here at Edge Computing World today. So let me introduce myself. I'm Marco Carrer. I am CTO of Eurotech. Eurotech is a company which has been powering the edge with hardware and software components for the past almost 30 years, right? We have offices in the US, in the UK, in Italy, and Japan. And we have been serving global 2000 companies worldwide, right? Trying to enable them through the edge computing adoptions. So today we're going to be talking about what we can do as technology providers, as companies like Eurotech, to simplify that adoption, right? To how to take the edge computing paradigms into new applications. Of course, I have to show you the disclaimer, but I think we can skip over that. Thank you. So we have been talking about edge computing for the past 3 days, right? Edge computing follows the data gravity principle. It moves computing resources close to the data source. Of course, that brings a lot of benefits. I'm sure a lot of them has been touched, but briefly, we can summarize them into improved performance. By having compute resources next to the data sources, we can dramatically improve our response times. The latency of the response of our devices can be dramatically reduced to possibly even within milliseconds type of performance. Of course, edge computing is also an answer to the data explosion problem that we've been seeing. We have wind turbines that are generating terabytes of data, and we have autonomous cars that are generating up to 20 terabytes of data per hour. Simply transferring all the data to the cloud to do the right inference, for example, edge AI inference, is just not practical, not convenient in terms of an operational cost. So edge computing is an answer to that. It moves that processing close to the data sources, saving on the cost of bandwidth. Edge computing also enables disconnected operations. So shall we have a failure on the connectivity, or shall we have a failure on the server side, right? Edge computing ensures reliability on the operation and resilience across those failures. Last, edge computing is the answer for all those applications where governance and compliance regulation force the data to be staying within a certain perimeter, a perimeter around the origin of the source of the data itself. Application where data privacy and data security enforce the data to be enclosed within those certain borders that can only be addressed by edge computing. So the benefits are huge. And in fact, this has started a small revolution, the edge computing revolution. Gartner is predicting by 2025, 75% of the enterprise generated data will be created and processed at the edge. And of course, all those interest into edge computing application is forecasting an edge computing market size that can reach up to 44 billions by 2027, which is only 7 years from now. Of course, there are challenges. Edge computing is not as straightforward as it may look at first glance. In fact, I think to understand those challenges, we have to look a little deeper on where is edge computing. Well, it's probably easier to say what is not. So edge computing is not in a climate-controlled data center room, and that changes a lot of things. Edge computing spans across many different industries, right? It's not just applications, in industries, and that's a big difference. It's in manufacturing, it's in smart agriculture, it's in public transportations, it's in cars as autonomous vehicles, it's in site management, smart building, healthcare and hospital. It's in the base station for 5G infrastructure and energy distributions. The interesting part is that in all these possible deployment scenarios, edge computing may actually traditionally recall different type of computing models. If an asset has to be stopped, if it is overheating, traditional computing resources will actually look for maybe an MCU, a microcontroller that within a short period of time, or possibly millisecond, can stop that asset from overheating. If I'm actually moving up and I'm actually trying to create an IT infrastructure within an OT control plane to optimize the overall equipment effectiveness of a factory floor, I actually may be using an IoT edge gateway, where the response time is not within the millisecond anymore, is probably within the orders of 100 milliseconds, because I am aggregating multiple sources from IT planes. And in that case, I may have to interface with the PLC. I may actually have to interface with IoT data streams to actually enable the edge analytics and the edge AI that will drive my response. If I am considering a site, whether that be a factory floor or a smart building or even a train that can be considered a site, and I'm actually trying to adopt optimization strategies, I may actually be aggregating multiple data sources within the site. So again, possibly IT and OT data sources with external data sources and optimize the whole supply chain. In that case, I may be looking for workloads that may be more traditional IT, in addition to maybe more esoteric workloads for the IoT interfaces. And then finally, whenever I have AI and AI intelligence, there is always the training part and the inference part. A lot of the data that I may be acquiring through the 3 use cases I mentioned before has to be transferred to the cloud, where new training or new decisions will be made, new model will be evolved, and will have to be distributed back to the edge to continue into my constant evolution of edge inference. So edge computing as a goal is trying to bridge all this into a single IT-inspired architecture. No longer MCU and small microcontroller unit and dedicated GPU, but single hardware and software architecture that can give us the productivity, the management, and the benefit of the IT data center, yet into these industrial use cases. So we can say edge computing is ubiquitous, but it's certainly not homogeneous. So that poses some needs and some challenges. So scalable edge computing is one of the answers that we have seen. So we have seen edge computing platform that goes from the OT needs to the IT needs, right? So scalable computing that goes from the microcontroller to high performance GPU centers. I also need to aggregate many more data sources. I need to aggregate what we said in the OT and IT. I need to be able to bring in data from PLC and from sensors. And out of the data, I need to simplify the data acquisition and create digital twin models. I need a hardware that can consolidate workloads, functional safety workloads with IT workloads, with GPU workloads, all in a single box. And that hardware has to sustain the demanding vertical certification of each of the industry, has to sustain the tough environmental deployments with extreme temperature grades, shock and vibes, and demanding needs of rough deployments. Also, I cannot rely on a connectivity that is always present, and my bandwidth is very expensive, right? So these calls for different application strategies. Finally, there is a very expensive metric, which is any field visit is that extremely rare and extremely expensive. So when I put my data, my assets on the field, I have to be able to manage them and manage them remotely. That also exposes my infrastructure all the way to the field, and I have to ensure that my security is extended beyond the physical perimeter of my IT all the way to the field. Physical access, physical security may impose new threats. So within these sets of need and this set of challenges, Eurotech aims at offering answers, right? Answers that are composed by trusted as solutions that simplify your digital transformations. We start from the breadth of a large ad product portfolio. So it spans from edge IoT gateways that can be mounted on DIN-rail industrial installations, so side by side with your PLCs and your OT controllers, all the way to nano data centers that are combining server class CPU with data center GPUs for incredible AI inference or even AI training on the field. We will be discussing about this unit and how they can achieve such a high data density. Now, The breadth of the technology of the product is also complemented by the breadth of the technology, which allow an edge product portfolio that can consolidate a different type of workloads. I can have edge IoT gateways that combine functional safety workloads running in locksteps execution to control a robot or a machine, right? With IT workloads that perform data analytics, with GPU workloads that combine camera vision, for example, for quality inspections at the end of the line. I can do that also across the different verticals. The portfolio that we offer different vertical industry certifications, whether it's for regulatory certification, whether it's for industry or global certifications, right? And this certification spans in many of the characteristics of the product. They have to be taken into account at product design level, both in terms of IP rating for the tough environment, power protection, power insulations, I/O interfaces that are typical for your industries. Finally, edge computing is not just a hardware component. Edge computing is hardware combined with software. We talked about how important it is to take the software paradigm of the IT and deployment into these edge computing controller nodes so that we get an homogeneous software and hardware architecture stacks across the solutions. On that, Eurotech has always taken an open software approach. We recognize and we have developed over time edge framework that simplify data acquisition so that IoT data can become a constant and simple data stream. So for the edge AI operations within this IoT data, it's simplified the digital twin modeling for both interacting and actuating with assets that are connected to this edge from the edge or remotely from the cloud and create simplified visual edge processing. Now, we talked about the importance of the edge and the edge management. So once these assets are deployed in the field, we want to be able to constantly update them. We mentioned the update of the configuration, the operating system to ensure a constant secure operation fields, but also of the AI models. So the data that is sent to the cloud will train new models that have to be deployed into the field. We also want to be able to monitor these edge nodes themselves. So being able to collect diagnostic information, to be able to have interactive alerts and monitoring on the edge and in the cloud, including the functionality of being able to extend log analytics, a typical DevOps operation that are currently confined only in the cloud, all the way to the extension of the edge management. We should not forget that this has to be secure, and Eurotech is designing their product around the 62443 cybersecurity certification for industrial and control systems, which extend the cybersecurity practices of the IT to the OT processing, extending them all the way to the hardware with the TPM protection, secure boot, physical access, and anti-tampering of the devices themselves. The open software integration of Eurotech, of course, in these software components adopts emerging technologies like containerization and container orchestration as a single software paradigm of the edge architecture. Eurotech is, in fact, one of the founding members of the IoT working group and of the Edge Native working group within the Eclipse Foundation. Now, within this edge portfolio, we would like to spend a few minutes on the high-performance edge computing nodes because of their very interesting design and the incredible compute density that they offer. They are the results of years of research and development of Eurotech into how to pack using liquid-cooled server-class technologies into boxes that can be certified for demanding AI workloads in tough environments. The results is shoebox like the one that we show on these slides. We take server-class Intel Xeon CPU, all soldered down on boards, combined with soldered down RAM, the fastest possible, and in a solution that can sustain shock and vibe certifications of the automotive sector and of the defense sector. You can see how this is achieved. All the electronics is enclosed into a very strong and resilient mechanical cage that ensure consistent vibration between the mid-plane and the PCI Express cards that are slotted into the different configurations. The boxes adopt, in fact, an architecture that allows for flexible populations. We can have some of these boxes populated for high-speed data logging. We can in fact achieve up to 123 terabyte on NVMe storage with performance benchmark that are taking us to 80 gigabyte of sustained write operations per second. But I can also combine this with compute node or edge inference node, where I substitute storage nodes with up to 3 NVIDIA V100, that we are talking about cards that are a power budget of 300 watts. And all this is achieved by the solutions of the liquid cooling. Now, with these solutions, I enable operations like massive data collection with 20 terabyte per hour that we were describing before, autonomous cars. And even the mechanical solution of installing them through docking stations allow to collect all this massive data, bringing that back into the data center by just unplugging the unit and plugging it back into your lab. So compact liquid cool design for an incredible compute density, all for rugged and heavy duty environment. One of the applications that we have been working with this type of node with our customers is for in-vehicle high performance computing. This is for research and development customers in the autonomous driving. They have been using multiple of these nodes to, in fact, build a real data center in a vehicle. So by combining high performance logger, compute node, a high inference node with liquid cooled 100 gigabit switches that we also provide, it created a backbone that is equivalent of a data center within a compact environment that is no bigger than what can be fitted into the trunk of a car. Now, the sensors of cameras, lidars, and radars that are producing this massive amount of data now, they can all be channeled through a backbone infrastructure and be logged in real time for further analysis into the data center, and can also be processed by compute and inference node at the edge themselves. So as new models get developed, they can actually be tested, evaluated, and new data can actually be fed back in original format with no additional compression. So the highest possible quality is used for the training part in the cloud. The last use case I would like to mention you on how these building blocks can actually be used is on the smart rail. In this case, the customer is DB Cargo, so German operator of all the cargo trains in Germany and part of Eastern Europe, a fleet of 800 locomotives. They are the operator. The locomotives are provided actually by the suppliers, and they have their own board. They are a mine of data, really. They have 5,000 plus data points with incredible frequency of updating. If they can extract that data and operate on that data both at the edge and in the cloud, they can achieve untapped operational efficiency. One of the goals here was to be able to perform the analytics on all that data on the locomotive itself, so on the edge. In fact, when these trains are crossing the Black Forest, connectivity is at all not guaranteed. So they have to be able to deploy edge analytics within the locomotive, and the locomotive has to be able to take autonomous decision to monitor threshold signal, both the operator and the cloud, on possible maintenance, emergencies of operational efficiencies they can actually deploy by, for example, monitoring things like the sand level into the sand that is needed for their power breaks. This was achieved through edge railway certified edge nodes with a flexible edge analytics software that allowed both the data acquisition as well as the creation of edge data pipelines so that could be constantly updated through the cloud and remotely. So in fact, we have been creating a locomotive digital twin that through continuous cloud to edge updating could actually create the operational efficiency for simple application right now and future use cases going forward. So with this introduction, of course, we thank you for attending. We invite you to visit Eurotech.com. and contact us. We're always interested to learn more about your project and your needs for edge computing. Thank you so much.
Marco, thank you so much for the presentation. Very instructive. We're done with this session, but a lot of questions we're going to have during the panel. So looking forward to your participation in the panel in 1 minute.
Thank you so much.